Hello, I'm Chris Malins of Serology, and I support the European Commission with the implementation of the GHG calculation under the Innovation Fund. In this presentation, we're going to talk about how to fill in the GHG calculation for applications for projects in the energy-intensive industries category. The energy-intensive industries section applies to projects that produce products that substitute a product whose conventional production is covered by Annex 1 of the EU ETS Directive, as well as any other innovative processing of biomass feedstock to produce bio-based products and biofuels in biorefineries. Note, though, that bioelectricity and bioheat, which had previously fallen under energy-intensive industries, have been moved under renewable energy sources. And you can see here some examples of sectors that produce products that are covered by Annex 1 of the ETS Directive and therefore would fall under energy-intensive industries. Projects in refining, in iron and steel, in non-ferrous metals, cement and lime, glass, ceramics and construction material, pulp and paper, hydrogen production, chemicals, and the manufacturing of components for electrolyzers. Other EII products include electricity, carbon dioxide transport, and carbon dioxide storage. The system boundary for the greenhouse gas calculation under the energy-intensive industries methodology must include, at the very least, the innovative practices and any processes downstream of those innovative practices which are necessary to produce the product. And it may include upstream processes where they fall within the scope of the project. This could mean that an application includes processes which are located at physically separate locations. Transport emissions are generally excluded from the calculation, with a few exceptions. Carbon dioxide transport for CCU or CCS must be included, and that falls under the carbon capture credit calculation. Distribution emissions for a product which is physically different to the one that it replaces. So an example would be hydrogen used in transport replacing diesel or gasoline is a physically different product, so distribution emissions would have to be considered. We also have biomass or waste materials and refundos that have been transported for more than 500 kilometres. It is required that you consider transport emissions for those as well. You must consider material and energy inputs. So that would be energy brought into the system, any materials and consumables brought into the system using emission factors derived from the input data hierarchy. And you may include changes to in-use emissions from products. And that is a choice for the operator to claim that a reduction in in-use emissions has been delivered by the product, and that needs to be characterized in the project scenario only. Finally, we have end of life, including the combustion of products, and that has to include not only carbon dioxide emissions, but also any methane and nitrous oxide arising from combustion of products. There are some changes to draw your attention to if you've applied under a previous call. So for the 2025 call, we have removed the concept of non-principal products. So now the term principal product refers to the single product that is the main aim of the project and that is used to determine the sector. Any other products will be assessed following much the same rules as co-principal products were assessed with in previous calls. The combustion box has been integrated into the end-of-life box, so you'll be calculating those emissions as you would have before, but the distinction between combustion and end-of-life in the calculators and in the methodology sections has been removed. There's a revised treatment for RFNBOs and for low-carbon fuels that are used as inputs. We have removed the notion of rigid inputs, but there are now additional rules defined for waste materials used as inputs and for inputs that have no economic value. And we have revised the treatment of timed operations. So in the case that a facility can have its operation time so that it does not consume electricity during periods when the carbon intensity of electricity from the grid is relatively high, we will now be asking you to undertake a hybrid application as an energy-intensive industries energy storage hybrid project rather than calculating a credit term within the energy-intensive industries methodology. Now, correctly establishing the reference scenario emissions is central to an application, and the reference scenario must represent the emissions from the conventional production of an equivalent quantity of products. In the case that the product produced by a project is physically similar to the conventional product, we ask you to assess the production of an identical quantity of product. In the case that the product is physically different, we ask that you assess the production of a quantity of the conventional product that would provide an equivalent function. So looking at hydrogen again as an example, if hydrogen is supplied to fuel cell vehicles, then the equivalent quantity of gasoline for the fossil fuel comparator calculation is calculated with the use of an energy efficiency ratio for a fuel cell vehicle. There are still 9 cases for the reference scenario, and a project that has multiple products may have to sum reference emissions across multiple reference cases. Given that we now have no non-principal products, all of the products from the project must be assigned a reference product. That's a change from previous years. But note that case 9 is in some respects operationally similar to the previous requirement for non-principal products because it refers to values from the data hierarchy. However, case 9 can only be applied when other cases are not applicable. So if you have applied with a non-principal product in a previous year, you may have to consider whether the calculation has to be different under the new rules. There are 9 cases for setting the reference emissions for the project. The first case is the case that a relevant EU ETS product benchmark, or a combination of product benchmarks, exist that describe the conventional production of the alternative product. And in general, if that EU ETS product benchmark is available, then it has to be used in the reference scenario. The exception to that would be the case of a modification to an existing production system where a ETS product benchmark is applicable, which we will talk about in a moment. The second case is that an appropriate reference scenario can be constructed from a combination of EU ETS product benchmarks and of other sub-installation benchmarks. So that could cover the case that your project can be described by a combination of a product benchmark and, for example, additional heat consumption as a heat sub-installation benchmark, or additional fuel consumption as a fuel sub-installation benchmark. The third case is the case of a modification to an existing production system. A project may be treated as a modification of an existing production system if emissions reductions are delivered by modifying one or more units or processes in an existing system in an innovative way, but without simply replacing the main processes. Projects that add carbon capture units to existing installations may be treated as modifications to the existing system. And with the exception of projects that add carbon capture units, the capex associated with the project must be no more than 1/3 of the capex for a new facility for it to be treated as a modification. The fourth reference case is a transport fuel substitute, in which case there are fossil fuel comparators defined that are applicable for gasoline type fuel, diesel type fuel, aviation fuel, and shipping fuel. The fifth case is the case of a natural gas substitute, in which case the reference scenario emissions are based on the use of natural gas. And the sixth case is the case that the product can be synthesized from natural gas and that a life cycle emission value is available in the data hierarchy. And in that case, the value from the data hierarchy may be used. The seventh case is the case of direct air capture for CCS, in which case the reference emissions are 0 and there are specific rules for setting the relative emission avoidance. The eighth case is the case of storage or transport of captured CO2, in which case the reference emissions are defined as the physical amount of carbon dioxide entering the system boundary. And finally, if none of those cases apply, then the ninth case allows the applicant to propose a reference scenario, and that could include proposing a value from a life cycle analysis commissioned by the applicant. The first box in our emissions calculation is the inputs box. All material and energy inputs that enter the system from outside the system boundary have to be considered under the inputs box, examples being heat, electricity, chemicals, feedstock, and biomass. But note that fossil fuels that are consumed within the system boundary are dealt with separately under the processes box and do not need to be included as inputs. As in previous years, Some minor inputs may be disregarded as de minimis and given an emission factor of 0. And as I mentioned earlier, we have removed this year the notion of rigid inputs, though there are now rules in relation to the use of waste inputs. Recycling is still a higher use on the Waste Framework Directive than energy recovery, and projects must demonstrate that they have complied with the expectations of the Waste Framework Directive. But in the case that waste inputs are displaced from landfilling or from incineration with or without energy recovery, then applicants are permitted to include a credit in relation to the use of those materials in their calculation. For all other inputs, we assume that production has increased. In the case of input electricity, that is assigned an emission factor of 0 tonnes of carbon dioxide per terajoule, reflecting the expectation of decarbonisation of the European energy grid in the years to come. For heat used as an input, the emission factor is 47.3 tonnes of carbon dioxide per terajoule, which is the EU ETS heat benchmark. While for input biomass, where available, disaggregated default values from the Renewable Energy Directive Annex 5 should be used. For inputs of renewable or of low-carbon hydrogen, emission factors of 0 tonnes carbon dioxide per tonne and 2.4 tonnes of carbon dioxide per tonne should be used, respectively. And in order to qualify for that treatment, hydrogen must be produced as defined in the case of renewable hydrogen in the Renewable Energy Directive, and in the case of low-carbon hydrogen, as defined in Directive 2024/1788 on the common rules for the internal markets for renewable gas, natural gas and hydrogen. Other inputs of hydrogen are assigned the EU ETS benchmark value 6.84 tonnes carbon dioxide per tonne. And inputs of other renewable fuels of non-biological origin or of other low-carbon fuels are assigned input emission factors of 0 tonnes carbon dioxide per terajoule or of 20 tonnes of carbon dioxide per terajoule, respectively. Emission factors for other inputs must be chosen from the input data hierarchy, which is Appendix 1 in the methodology. And applicants must justify the choice of emission factor, must not use EU ETS benchmark values for these other inputs, and may need in some cases to adjust an input emission factor found in existing literature to make sure that they exclude carbon content to avoid double counting. Note that unlike some previous years, applicants are not permitted to make a 15% upstream adjustment to input emission factors. The second box in our calculation is the processes box. Process emissions must include all carbon dioxide from fuel combustion within the system boundary, and any other emissions of carbon dioxide, methane or nitrous oxide that occur within the system boundary. Where required, transport emissions should be included under processes, and any change in emissions associated with the processing of process waste should be included in the processes box. Note though that the treatment of emission reduction through timed operation has changed this year. This is no longer to be recorded as part of process emissions. Instead, the electricity from virtual storage is to be treated as a project, and the application must be a hybrid EII energy storage application, giving an emission value for the electricity from virtual storage following the energy storage methodology. The final box that applies to both the reference and the project scenarios is the end-of-life box. When products contain carbon atoms, then the applicant must consider the fate of those atoms at end of life. And as I mentioned earlier, the end-of-life box now also includes combustion of products. If carbon atoms will be combusted, the end-of-life carbon dioxide emission must be considered here. But if carbon atoms will be recycled into new products, then there is no need to include an end-of-life emission. If the carbon will be incorporated in a material that is listed as permanently chemically binding carbon under the emission trading scheme, then again no end-of-life emission must be included. And if incorporated in materials that have a useful lifetime of at least 50 years, then only 50% of the contained carbon has to be assumed to be emitted. Finally though, if carbon is incorporated into materials that have a useful lifetime of less than 50 years, then the end-of-life box must assume that 100% of that contained carbon is emitted. The end-of-life box must also include any expected non-CO2 GHG emissions that occur at end of life, and other reductions in end-of-life emissions compared to the reference scenario may be included as a negative emission, as a credit. Do consult the available resources before preparing your applications. There are 5 Excel examples of energy-intensive industries projects that are being made available to illustrate the use of the GHG calculators. 1, a project to produce green hydrogen. 2, a project to produce renewable methanol. 3, a project to produce e-fuels. 4, a direct air capture project. And 5, an electrolyser component manufacturing project. And there's a link to the examples here. Thanks very much for watching this video. Good luck with your applications.